Okay, part 2. So looking at number 9, this time they're giving me the angle and they want me to find the measure of an intercepted minor arc, meaning the arc that's smaller, not the bigger of the two. So if there are two arcs that fit inside of these angles, then I want the smaller, okay? So just like the other questions, the first thing I want to do is find all the spots where our two pieces intersect the circle. So if that's at Y and at Z, I realize I do have two arcs. I have arc YZ, which is the one they're asking for. I also have arc YDZ, this major arc. And so they don't really tell me anything except that the measure of angle X is 60 degrees. What I do know, though, is the formula. And the formula says that the measure of the angle is equal to the far arc minus the close arc divided by 2. Okay, so what we're looking for is that close arc. So I'll make that my X. And now, what's the far arc? Well, I do know that an entire circle is 360 degrees. Okay. And I don't know what the close arc is, but I do know that the further arc, the blue one, would end up being whatever, well, 360 minus whatever that close arc is. So let's say it's 360 minus that minor arc, right? So I'm actually going to use that in my equation. That's all I know. That's all I can use. So 360 minus X minus the minor arc, right? This is, oops, let's kind of tidy this up a little bit more. This is the measure of the blue arc, 360 minus X. And then we're subtracting the minor arc, divide by 2. So the measure of angle X is 60, so I'll substitute that in as well. So this is my equation, and now we use this to solve for X. So let's neaten up that numerator a little bit. We have 60 equals 360 minus X, so really means minus 2X. Divide by 2. I can simplify this. I have 360 divide by 2 minus 2X divide by 2. So I have 60 is equal to 180 minus X. Our goal is to solve for X, so I could do something like subtract the 180 from both sides. That's going to get me negative 120 is equal to negative X. And so if I wanted to solve for positive X, I can divide both sides by negative 1. And I get that X is positive 120, which means that if X represented our minor arc YZ, our arc is 120 degrees. Okay, let's try that again. Again, let's find the spots where our sides intersect the circle. So that shows us we have two arcs. We have arc DE, which is the minor arc. We also have arc DPE, which is our major arc. So let's go through that process one more time. The measure of the exterior angle here, so that 100-degree angle, is equal to the measure of the far arc minus the measure of the close arc. Divide by 2. The close arc is what we're looking for, so that's our X. The far arc, all we know is the full circle of 360 minus the arc we're looking for. So 360 minus X, that's the measure of our far arc. So once again, we simplify. 100 is equal to 360 minus 2X, divide by 2, which means 100 is equal to 180 minus X. I can subtract 180 from both sides to get negative 80 is equal to negative X. And when I divide both sides by negative 1, I get X equals 80. Since X represented our minor arc, and that's what we're looking for, our minor arc is 80 degrees. Okay, next. Okay, so in these exercises, they tell us a couple of things. We know that line CD is tangent to the circle, so we know the only spot it's going to intersect the circle is at this point of tangency P. We also know that this entire angle is 70 degrees, not just in between the side and the circle, it's the entire thing. And what we discussed in the last video was that if I know that angle and its vertex is on the circle, then the entire arc that fits inside of that angle is going to be 2 times that angle measure. So when they're asking, I'm going to actually jump to number 2 first. I know that that arc is 2 times that 70-degree angle, so that's 140 degrees. I can go back to number 1 now. The measure of angle ABC. ABC is this one here. We'll notice it's a linear pair with the angle they gave us, so it's supplementary to 170. So if I do 180 minus the 70, I'm going to get 110 degrees. Next, they want the measure of arc AEB. So they want this entire arc here. Let me get a different color pen. So AEB. And if I pay close attention, I realize that that entire arc fits inside of this angle, right? That's the entire intercepted arc for that angle. And we just said that entire angle was 110 degrees. That arc is going to be 2 times the 110 degrees. So that entire arc is going to be 220 degrees. Okay, question 4 and 5. In these two, they tell us a couple of things again. They tell us the measure of arc ADB. So from A through D and stopping at B is 220 degrees. They also tell us the measure of angle B is 21. Find the indicated measures. Okay, so they want us to find the measure of arc AB, and that's minor arc AB. So they want us to find this. And well, hey, notice that the red arc and the green arc make up the entire circle. And the red arc we know is 220. So if I do the full circle 360 minus the 220 we know, we're going to get our other arc AB. So 360 minus 220 tells us that this arc AB is going to be 140 degrees. Next, they want the measure of angle ACB. ACB, so they're looking for this angle right here. So it might take a moment to really realize what they're asking for here, but we can go back to thinking about, well, why in the world did they tell us that that's 21? Here's something to realize. We have a triangle. Sometimes they like to throw these shapes in to make sure you're paying attention. If I have a triangle, I know that all 3 angles add up to 180. Right? I already know this one's 21. I know I'm looking for this angle. So now the question is, do I know this angle A? And the answer is yes, because angle A has 220 degrees as its intercepted arc. So this angle A is half of that, which is 110 degrees. So out of my triangle, I have 2 out of 3 angles. So if I subtract the 2 I know from 180, So 180 minus the 110 minus 21, I find that this angle is 49 degrees.